welcome to Foundational Mathematics Session 1. In this session, you will explore all the main mathematical concepts that are covered under ELO 1. You'll refer to the materials in the Foundational Mathematics package and other resources you can use to make these concepts easy, interesting, and relevant to your students. The purpose of ELO 1 is really to address the basic foundational knowledge that many students do not have when they arrive at colleges. The second purpose is to identify the gaps that students have in their prior knowledge and to cover these gaps so that everyone can start with a solid foundation for further learning. You will need to spend a lot of time making sure that everybody masters these core skills, as without this, they are going to struggle to cope with the ELOs that follow. Let's look at what you'll cover in ELO 1. There are 9 learning outcomes. Maths anxiety is a big issue for many of our students. You'll see their eyes glaze over, and it may be difficult to get them to summon up the courage to even try. Starting with simple concepts gives your students a chance to be successful. Initial success is vital to undo years of negative experiences with maths. Build confidence in all your students by starting off slowly. Be patient and make sure you keep everyone with you as you move on to more difficult concepts. Adding in an element of fun through games and exciting group activities will help alleviate their anxiety. The foundational maths curriculum takes students back to the very beginning. The first learning outcome deals with adding and subtracting counting numbers. This is introduced using simple number lines. Shown another way, these are counting numbers. These are whole numbers and these are integers. Now let's look at the addition and subtraction of counting numbers using number lines. An example of addition is 1 plus 1 equals 2, plus 1 equals 3, then 3 plus 3 equals 6. This may seem to be very simple, but it is important for students to get the underlying principles of moving to the right when adding and moving to the left when subtracting on a number line. This will help them to understand the rules we come to later on. Students who have had negative past experiences may simply tune out when it comes to learning maths. But if they understand the reason for learning something and see that it's relevant to their lives, they'll be more motivated to overcome this block. Here are just some of the ideas that may have come up in your brainstorm session. For most of us, money is an extremely tangible and motivating factor. Putting an abstract mathematical problem into rands and cents can make it instantly more real, practical, and solvable. Numbers are relevant to all business studies. Measurement is a vital part of many careers. be it working in engineering, construction, transport, manufacture, or in the sciences. Size, weight, height, time, distance, temperature, and dates are all factors that have human interest. The trick is to make them interesting to your teenage humans. What interests them? What problems do they want to solve? Make numbers interesting. So ELA 1.2 deals with integers. Again, begin with simple number lines. Let your students experience the feeling of success. Start with adding integers. Again, students move to the right when they add integers. So, if you start at -3 and you add a +1, you get to -2. -2, adding a +1 again, you get to -1. And if you add a +3 to -1, you get to +2 on the number line.
Two. 3. And -4.
Note that number lines are not always represented in a horizontal format. For example, on a thermometer, the number line is vertical. In this case, numbers get bigger as they go up and smaller as they go down. Students will encounter vertical number lines when they start working with data on graphs.
Here's an example of a simple game you can play with your students. Collect objects that can be used as counters. You'll need 2 distinct types, such as red and blue bottle caps or stones and leaves. Mark each counter as either +1 or -1 according to its type. Count out as many positive and negative counters as you need to represent numbers according to an equation. In this example, we have +5 plus -3. Divide the positive and negative counters and arrange them in lines. Then move one line below the other. A number of counters will be left without a partner. This is your answer to the equation.
Students need to understand and learn to follow rules on addition and subtraction of integers. 2 signs that are the same become a positive sign. 2 signs that are not the same become a negative sign. Students need to work with lots of practical examples and may need to use concrete items such as counters or bottle tops as you saw in the video. You cannot assume that students have understood that multiplication is repetitive addition. For example, 4 times 3 is the same as 4 plus 4 plus 4. Students need to understand and learn the rules on multiplying integers. These rules are the same as those for addition, as multiplication is really just repetitive addition. 2 positives make a positive number. 2 negatives make a positive number. A negative and a positive make a negative number. And a positive and a negative make a negative number. Likewise, you cannot assume that students have understood that division is actually repetitive subtraction, which means taking away the same number again and again. For example, 12 divided by 4 equals 3 is the same as 12 minus 4 and minus 4 again. You will need to make sure that students also understand and learn the rules on dividing integers. These rules are the same as those for subtraction, as division is really just repetitive subtraction. Two positives make a positive number. Two negatives make a positive number. Again, a negative and a positive make a negative number, and a positive and a negative make a negative number. Now you're going to do an activity that will generate a list of keywords that will be very useful for your students. Learning Outcomes 1.7 and 1.8 deal with fractions. The terminology around different types of fractions and working with the 4 basic operations. You are now going to watch how Eddie Wu introduces fractions to his students. If you've never come across Eddie before, you are in for a treat. He is famous for his website called MrWuTube.com, and he has been acclaimed for his best practice maths teaching and has won numerous awards. As you watch, see if you can pick up any new teaching tips.
What was the very first topic that we started this year? Do you remember?
Integers.
Integers. Perfect. Now, you remember I made a big deal about the name integers, and it had a meaning, right? What was it? Why are integers called integers? Yeah, Morgan.
Because an integer is a whole number.
Exactly right. An integer, right? Where we get the word integral from, which means, all in one piece, not falling apart. It means whole. Okay. And now we are looking at fractions. Okay. Now, I think you guys can do a pretty good job here. I'm going to ask you to do this on your own for a second. I want you to write down a definition for fractions are. Okay, and I expect we'll get a few different ones, okay? But I want you to write down, because I know you've met these before, I want to see what kinds of meanings, definitions. Give me a sentence. What is a fraction? Okay? I'll give you some time to write that down, and then I'll share, we'll hear some of what you have to say. Okay. All right. So let's see what we can come up with. Let me get my other color. All right, a sentence. Yes? Shh. Yeah, you.
Okay. A fraction is a section or part of a shape.
Ooh, section or part of what, sorry?
A shape.
Of a shape. Okay. Excellent. I love this idea. Okay. Let's go in the front. Yep.
A fraction is a part of a whole, like a whole number, a whole shape, or a whole.
Okay. Part of a whole, and then you might have something after this, number, shape, something like that. Okay, good. Can someone give me one that's different? Yeah, Rashad.
Well, can I say like fraction is part of anything?
Ooh, part of. So the important thing is that, right? A part of anything. Okay, can someone give me anything different? Yeah, Ali?
They're not whole numbers.
Not whole numbers. Not whole. Okay, all right, and one more. No.
They're part of. They're a little part of everything.
A little part. Maybe I'll put it on.
That's something different.
Little. Okay, all right. Now, does anyone have anything that's dramatically different to any of these?
Pi is also.
One last one, Jasmine. Ooh. Okay. Okay. All right. Now, I like all of these ideas. I think we're getting at it, right? Now, I hope you can see why I wrote down integers first, because fractions are very much a contrast to integers, right? Integers does sound a bit cool, but integers sounds like a word you know. That means whole, right? Fractions sounds like another word you know, doesn't it? Does it not sound like fracture? Fracture? When you fracture something, right? Makes sense? Integers are whole numbers, because integral means whole, right? In one piece. But fractions, they're broken numbers. They're numbers that have been split apart, divided, okay? Literally fractured into pieces, and you only have a part of it. And you saw that language there. This is one of many kinds of numbers. Integers are some, fractions, but there are many other kinds, right? But fractions is what we're going to focus on for this topic, okay?